Now here on 5, notice that I have a piecewise defined function. And the function's defined to be 0 when t is less than 1, and then defined to be t squared minus 2t plus 2 when t is greater than or equal to 1. So when I set this up using my Laplace transform, because it's piecewise defined, I'm going to use those limits, or those portions of the domain, to define this, to set up my integrals. So notice that my integral for my Laplace transform goes from t equals 0 to t equals infinity, or the limit as t goes to infinity. And so I want to start where t is equal to 0, and I'm going to break this portion up into two integrals. I'm going to look from 0 to 1, I'm using this definition, and then I've got from 1 to infinity, I'm using the second definition. So from 0 to 1, I get e to the negative st times 0 dt. And then from 1 to infinity, I get e to the negative st times t squared minus 2t plus 2. On this first integral, 0 times anything is 0. And on the second integral, I want to multiply this out so that I have 3 terms that I'm working with. And I'll actually have 3 different integrals that I'll be working with. I have e to the negative st times t squared. Let me bring out the negative 2. And my second integral will be e to the negative st times t. That 2 came out front. And on the third integral, I'll bring that 2 out front, and I'll have the integral e to the negative st. Okay, for a definite integral, well, when you take the integral of 0, you just get that constant. But with a definite integral, you don't even include the constant. So this whole first integral is just 0. This second integral, when you integrate e to the negative st times t squared, let's see if it makes a difference, because our limits don't go from 0 to infinity, but they go from 1 to infinity. So here we want to use integration by parts. I'm going to let u equal t squared, and du will equal to 2t dt. dv equals e to the negative st dt. And v is e to the negative st divided by negative s. To do the integration by parts, I get u times v. That gives me t squared e to the negative st divided by negative s. Evaluate that for 1, and the limit as t goes to infinity. and then minus v du is e to the negative st over negative s times 2t dt. And my limits go from 1 to infinity. That's the first part of this first integral. And then for my second integral, I have minus 2. I'm going to carry out. Here I also need to do integration by parts. And my dv and my v are here. In this case, I'm going to let u equal t. And du is equal to dt. So on this second integral that I have, I'm going to get uv. That's going to be t e to the negative st divided by negative s. Evaluate that for 1 and the limit as t goes to infinity. And then minus v du. Minus the integral 1 to infinity e to the negative st divided by negative s dt. And for this last integral, I've got plus 2, and here I can integrate e to the negative st. When you integrate that, you get e to the negative st divided by negative s, and then apply your limits. The limit as t goes to infinity and 0. So let's see what we have. This first term dropped out. Here, when you take the limit as t goes to infinity, as long as this exponent has a coefficient that's positive, then this will converge to 0. And so we want to make the condition that s is positive, greater than 0. I think I said that wrong. We want s to be greater than 0 so that this coefficient of t is negative, so that at infinity e to the negative power goes to 0. And there we go. And at infinity then, as long as s is greater than 0, this term will go to 0. You're going to end up with 0 minus, and then at 1, here I get 1 squared e to the negative 1s, e to the negative s, over negative s. That was at 1. Okay, so I'm done with this. And then I have minus, let me take, yeah, I have minus and I have minus, and here I'm going to need to integrate some more. So let me rewrite this as a plus 1 over, actually plus 2 over s, and bring out the 2, bring out the s, negative and negative give you a positive, and this integral goes from 1 to infinity, and I'll get e to the negative st times t dt, and I'll integrate that by parts in just a minute. And then I have minus 2 so let's see, I think that this 2 gets multiplied by both of these terms. Factor out the 2 before we did integration by parts, and so that integration by parts should go with both of these terms. So that minus 2 should go outside everything. here as t goes to infinity, e to the negative st will go to 0 as long as s is greater than 0. So that's going to give me a 0 when t goes to infinity, minus at 1 I get 1 e to the negative s over negative s. So let me bring those negatives together to give me a plus here. Minus, and here I can do integration. Well, let me just carry that 1 over s out first. I'm going to bring the negative s out. That'll change that to a plus 1 over s. And I've got integration 1 to infinity. And I'm left with just e to the negative st dt. I'll do that integration on my next step. Close my braces. And then plus 2. And now when I apply my limit as t goes to infinity, this will go to 0. And my lower limit shouldn't be 0, it should be 1. And then at 1, I'm going to get e to the negative s. So get minus e to the negative s over negative s. So let's see what we have. On this first term, these negatives drop out, and I get just e to the negative s over s. On this first integral, I'm going to integrate by parts. I'll use what I have here, u is equal to t, du is equal to dt. dv is e to the negative st dt, and v is e to the negative st divided by negative s. I get my uv minus v du. There it is. Okay, so I get my u v t e to the negative st divided by negative s. My limits are as t goes to infinity and 1, and then minus v du e to the negative st divided by negative s dt. Okay, and that takes care of this. Minus 2. This is just e to the negative s over s plus 1 over s. And here I can integrate e to the negative st to get e to the negative st divided by negative s. And I have my limits as t goes to infinity and at 1. Close my braces. And then I have 2 minus a negative gives me a plus. This becomes 2e to the negative s over s. Okay, now I should be able to do most of my calculations. I have e to the negative s over s plus 2 over s. Here when I apply my limits, limit as t goes to infinity, we'll drop this out. It'll become a 0 minus at 1, I get 1 e to the negative s over negative s. So the negative s and the minus cancel each other out. Minus when I integrate e to the negative st over negative s, I can bring the minus and the negative together, and that'll give me plus 1 over s, that's bringing the s out, and then integrating e to the negative st gives me e to the negative st divided by negative s, so that's going to put the negative back in and give me an s squared, and here my limit should be at 1 and infinity. T goes to infinity and 1, and I'll close my braces. So minus 2 e to the negative s over s plus 1 over, that'll be an s squared, and it'll be a negative s squared. And then when I take my limit as t goes to infinity of e to the negative st, that drops out. And at 1, I get e to the negative s. Plus 2e to the negative s over s. So I only have one more limit to apply, and then I can start combining terms. I have e to the negative s over s plus this, when I distribute through by my, I'm going to start trying to get rid of some parentheses and groups. This will become 2 e to the negative s over s squared, and then this will become 2, it's actually a minus, 2 over s to the third, and here I need to take the limit of e to the negative st at infinity, gives me 0, and at 1 is going to give me e to the negative s. That's a 2, and if I distribute through by negative 2, I'm going to get negative 2 e to the negative s over s. This negative 2 and that negative will give you a plus 2 over s squared times negative e to the negative s. That changes it to a negative again. And then plus 2 e to the negative s over s. Okay, so let's see what I have. I see that this term, negative 2 e to the negative s over s, and this term, 2 e to the negative s over s, are opposites. They cancel each other out. This term, negative 2 e to the negative s over s squared and 2 e to the negative s over s squared, these are opposites. They cancel each other out. So I'm left with an s term, and I'm left with an s in the denominator, and I'm left with an s to the third in the denominator. If I factor out the e to the negative s, that'll leave me with 1 over s plus 2, those negatives will cancel, they'll give me a plus 2 over s to the third, that's all I'm left with. And